Have you ever looked at a water tank, a soda can, a football, or an ice cream cone, and wondered how engineers know exactly how much material is needed to make them? How do architects know how much paint is required to cover a wall? How do manufacturers know the amount of metal needed to produce a gas cylinder? The answer is mensuration. Today's lesson is one of the most important topics in mathematics. By the end, you won't memorize formulas. You'll understand where every single formula comes from. Let's begin. Mensuration is simply the mathematics of measuring shapes. There are two things we usually measure. The first is the amount of space covering the outside. The second is the amount of space inside. These are completely different ideas. Suppose I give you this gift box. If I want to wrap it with wrapping paper, I only care about the outside. That is called surface area. Now imagine opening the box and filling it with chocolates. Now we're measuring the inside. That is called volume. Surface area means covering. Volume means filling. Never confuse the two. Everything begins with shapes you already know. A rectangle becomes a box. A circle becomes a cylinder. A triangle can rotate to form a cone. A semicircle, rotated around its diameter, forms a sphere. Three-dimensional shapes are simply two-dimensional shapes with depth. Think of it this way. A sheet of paper is flat. Stack thousands of sheets together, and you have thickness. That thickness creates volume. Surface area tells us how much material covers the outside of an object. Imagine painting your bedroom. You don't calculate how much air is inside the room. You calculate the walls that must be painted. That is surface area. Imagine wrapping a birthday present. The paper covers only the outside. Again, surface area. Imagine manufacturing a soda can. The aluminum sheet wraps around the outside. Surface area again. Whenever you hear paint, cover, wrap, label, or polish, think surface area. Volume measures how much space exists inside an object. Imagine filling a swimming pool. We don't care about the walls. We care about how much water fits inside. That is volume. Imagine filling a fuel tank. Imagine filling a grain silo. Imagine filling a water bottle. Those are all volume problems. Whenever you hear fill, contain, capacity, store, or hold, think volume. Let's begin with one of the most useful solids, the cylinder. Examples include water tanks, gas cylinders, pipes, drums, candles, and soda cans. A cylinder has two circles and one curved surface. Now here's something amazing. Watch carefully. If we cut the curved surface and unwrap it, it becomes a rectangle. This is the secret behind the formula. The width of the rectangle is not random. It is exactly the circumference of the circle, which is 2 pi r. The height stays the same. The area of a rectangle equals length times width. So 2 pi r multiplied by h gives the curved surface area. Then add the two circular ends. Each circle has area pi squared. Since there are two, we add 2 pi r squared. Finally, factor out 2 pi r, and we obtain 2 pi r multiplied by the quantity h plus r. Now students never need to memorize this. They can derive it. Think of a cylinder as many circles stacked together. Each circle has area pi r squared. Multiply by the height. Volume equals pi r squared h. Area of the base multiplied by the height. Exactly like multiplying length by width by height for a cuboid. Now comes one of the most beautiful discoveries in mathematics. Imagine a cone and a cylinder having exactly the same base and exactly the same height. That means one cone contains 1/3 the volume of a cylinder. Since the cylinder volume, the cone volume becomes 1/3. You never memorize it. you understand it. The sphere is perhaps nature's favorite shape. Planets, soap bubbles, balls, water droplets, even many fruits. A sphere has no edges, no corners. Every point is exactly the same distance from the center. That distance is called the radius. The surface area is 4 pi r squared. The volume is 4/3 pi r cubed. These formulas were discovered over 2,000 years ago by Archimedes. He was so proud of this discovery that he asked for a sphere and a cylinder to be carved onto his tombstone. That is how important this idea was. Students usually don't fail because they don't know formulas. They fail because they choose the wrong one. Here is the easiest trick. If the question says paint, wrap, cover, label, or polish, use surface area. If the question says fill, store, contain, capacity, or water, use volume. This simple trick will save you many exam marks. Let's solve one example. Find the volume of a cylinder with radius 7 centimeters and height 10 centimeters. Step 1. Write the formula. Volume equals pi r squared h. Step 2. Substitute the values. Step 3. Square the radius. 7 squared is 49. Multiply by 10. The final answer is 490 pi cubic centimeters. Notice how simple it becomes once you understand the formula. Today, you've learned something much more valuable than formulas. You discovered why those formulas exist. Remember these key ideas. Surface area covers the outside. Volume measures the inside. A cylinder is a stretched circle. A cone has 1/3 the volume of a matching cylinder. A sphere is the most perfectly symmetrical solid in nature. When you understand the ideas, the formulas become easy to remember. In our next lesson, we'll solve challenging examination questions that combine multiple solids, requiring you to apply everything you've learned today. Keep practicing, stay curious, and remember, mathematics isn't about memorizing formulas. It's about understanding the patterns that shape our world.